Hello, everybody, and thanks for joining this session about the State of ProxySQL 2020 edition. I am René Cannaò, and I'm your host. I am the founder of ProxySQL, and I'm developing it since 2013. So, a quick introduction about what we do at ProxySQL LLC. So basically, we are the company behind the development of ProxySQL, and of course, our focus is to improve the performance and the reliability of MySQL infrastructure. Then specifically with regard to ProxySQL, we provide support services, and also we provide development of the product itself, and also training. On this note, please note there is a training coming on next month between the 18th and 19th November. And besides this, we also perform CBRE and consulting services. We are hiring, so we are looking for C and C++ developers. If you are a developer that is interested to work in ProxySQL, please reach out. Now, here there is a very quick overview of few of the companies using ProxySQL. The list of companies using ProxySQL is growing day by day because it's becoming one of the standard, almost one of the standards of large MySQL infrastructure. Now, this is our agenda for today. We're going to have a very quick summary of the new features introduced in 2019. Of course, this presentation is about new features in 2020. So here we will have a very quick overview of previous year. Then we're going to speak about some performance enhancements we're introducing ProxySQL. We're discussing about the REST API, all the new features that were introduced in 2.0, and all the new features that are introduced in ProxySQL 2.1 to be released very soon. And then specifically to ProxySQL 2.1, we are going to discuss about the Prometheus exporter and the enterprise web UI. Now let's get into it. So the previous features, I'm not going to get into details because the session is very short, but in 2020 we had several new features were added. Specifically, we focus on performance enhancement. We did further work on the GDD causal read, so that allows us to have reads from replicas that are in sync with the primary node. Then we have native support for Galera, Percona XtraDB Cluster, Proxy maintenance mode, support for Amazon Aurora, the LDAP integration, a lot of enhancement related to security, so SSL and audit log. And we also have the general log in JSON format to make it more readable, and easy to digest by third-party tools. And then we have the admin interface that supports JSON function as well. Then we introduce the firewall whitelist, so ProxySQL can also act as a firewall. It can detect SQL injection attempt, and we add support for MySQL 8. Now, what is our focus for 2.0 event 2020? Well, we always strive to have better performance, so we are constantly checking the performance of ProxySQL and try to identify bottlenecks depending on workload, and we always try to address those performance. So every release we try to have some better performance. Now, in 2.1, we performed several upgrades to the dependency library. And specifically, we upgraded the MariaDB connector C that adds new features, and we also performed the upgrade of both the regular expression engines that are built inside ProxySQL. Furthermore, with regard to OpenSSL, we upgraded the latest stable releases, and that it has also further security enhancement and bug fixes. And also SQLite was upgraded to version 3.19.2. Now, not only we try to fix performance in the current release, so in 2.0, but also we perform extensive code refactoring in 2.1, so to make the code a bit more readable and better organized. So this happened in ProxySQL 2.1. Now, we also have several memory optimization. So our focus was not just on improving performance, but depending from the scale in which you are deploying ProxySQL, you might have high memory usage. So we try to make several changes to reduce the memory utilization in ProxySQL. Specifically, we upgraded JMalloc to 5.2.0. This had a big impact on memory usage, but we also optimize some of the statistic tables that ProxySQL use. So every time you are querying one of the tables in the stat schema, what ProxySQL does is it will process data that are stored in internal memory structure. It will write the tables using those data, and then it will run the query against that. On top of this, what happens is that those tables are in memory, so they will use memory, of course. We implemented a new feature that basically ProxySQL is able to delete those tables after it executes the query, and then it also call vacuum, so it will free this memory. So this has a big impact on memory utilization. Furthermore, if you are familiar with how ProxySQL stores the digest, when you query the tables of MySQL Query Digest, you will have username, schema, and metrics about the queries, including the digest text of the query. Now, if you have the same query pattern executed by multiple users, or even by the same users on different schema, you will have the digest text is repeated multiple times, one for every combination of username and schema. Now, what we did was that internally we are storing the digest text on a different memory structure. So we are basically normalizing the data that is stored on those memory structure. So this drastically reduced the amount of memory usage. Nonetheless, when you are querying the tables of MySQL Query Digest, the output you see is absolutely the same. Nothing has changed there. Furthermore, we made some changes on the table MySQL Query Rules Fast Routing, but I'm going to discuss this later on. REST API. This is a very interesting feature that we introduced this year. So basically, what it allows is to create REST API endpoint that ProxySQL will use to execute binaries or scripts in general. So the way it works is that ProxySQL will listen on a port and will accept HTTP connection. The client can connect and make a request to a specific URI. And optionally, the client can also pass some argument if required, depends on the script that you are configuring. And then ProxySQL will execute the configured script using eventually the option that has been passed by the client. And then the results that will send back to the client. Here there is an example of how this looks like. The URI that the client can hit with a browser, basically, or a HTTP client. So how to enable the REST API? Very simple. There are two variables that controls it. One is admin REST API enabled, and the other one is admin REST API post. The names are quite clear. So if you set admin REST API enabled to true, basically the REST API will be enabled and it will be listening on the port specified in admin REST API port. Now, how do you actually configure the URI and which script need to be executed? This happens through a table called REST API routes. So, of course, you probably know that everything ProxySQL you can configure through a table. So, and this is no different in this case. So, the table structure of this table is quite simple. You have an ID, you have an active field that is a similar pattern used in many other tables. So this active field could be either 1 or 0, if it's enabled or not. And then you have a timeout. So every time you execute a query, script, the script can run for a certain period of time. Here it is incorrectly named interval millisecond because this table was ported from a different one, but we are going to change the name into one, renaming it in timeout. Then you have the method, is either a get or a post. And then you have the URI, and that is basically the request that the client can execute, and then the script. So which script ProxySQL will call in case the client is going to hit that specific URI. Here I'm going to show a very simple example on how to configure one of such entries. So basically you run an insert into REST API routes, specifying all the columns, and you configure basically. So you here in this case specify that the query that the request has to have the endpoint called export user. The script is going to be called is script/export user.py, and it will be a post method. and the timeout will be 1 second or 1000 milliseconds. And here we can also see an example on how to code this endpoint using a post method and passing some data. In this case, the data we are passing is a JSON. It could be anything, but the script is configured to accept the JSON as data in. And in this JSON, what we are passing are mostly two objects. One is admin, that is basically store the credential on how the script can connect to ProxySQL admin itself, and another that is called DB, that are basically storing other credentials. What the script does is an example script, but what it basically does is it will connect to the DB specified in the request using those credentials. It will retrieve username and password, and then it will connect to ProxySQL admin and store those information. And this specific script, what it returns is another JSON. Could be anything, but in this case, it's a JSON that returns the parameter sent by the client itself, and also returns a result that is basically showing the number of records that have been inserted into ProxySQL admin. In this case, 8. In short, it has retrieved 8 users and brought them into ProxySQL admin. Now, all these features introduced in ProxySQL 2.0, while going to have a quick overview of them. We enable IO thread by default. This makes ProxySQL able to scale to tens of thousands of connections by default instead of having to manually enable this setting, and has better CPU utilization. Then previously I was mentioning that we made some change in MySQL query routes fast routing. Specifically, what we did is that we allowed fast routing lookup without username. So basically, if you're familiar with this table, you know that it has some algorithm to specify that if a specific users and schema, if a combination of user schema and plugin are provided, then it returns a destination host group. But if you have a lot of users, you basically have to configure the same per user schema for every users. So what we did is to allow the lookup without specifying the username. So this drastically reduced the memory footprint, but it also easy to configure because you don't have to create entry for every user in this table. Also in the same version, we made several enhancements related to SSL. We upgraded OpenSSL to the latest version, and also implemented the loading of intermediary certificate chain. This allowed the client to connect ProxySQL using the verify CI option. Also in ProxySQL 2.0.13, we introduced support for SafePoint that were previously not available. Up to this version, ProxySQL was only supporting transaction, but not SafePoint. Furthermore, we also introduced the annotation create new connection equal 1. If a client execute a query with this annotation and ProxySQL does not have a backend connection already associated with this client, instead of retrieving a client backend connection from the connection pool to execute the query, ProxySQL will create a new connection for the execution of such query. Then in 2.0.14, we had the option of compiling ProxySQL also on FreeBSD and on macOS. And also we fixed a bug that is now a feature that basically, if a client for whatever reason is not connecting to ProxySQL but does not complete the authentication within a certain period of time, ProxySQL is able to disconnect the client after this time threshold has passed instead of waiting forever for the client to complete the authentication. This might happen because of a network issue or any other reason. Also, we implemented an interesting feature to solve a problem that is if replication lag is spiking for whatever reason. For example, a long-running transaction that has committed on the writer, and even if the transaction is relatively simple and the replica are able to catch up replication very quickly, it is possible that replication lag will spike for 1 or 2 seconds. If ProxySQL is making the check during this very small time frame and detect that the replication lag is high, what it might do is that it disables the replica until the next check. So this will mean that the replica will be flipping status between online and shunned, and basically flipping between those two status. With the introduction of these variables, ProxySQL will perform multiple checks before changing the status from online to shut. And we also added packages for Ubuntu 20. And also, up to this version, we were providing two packages for ProxySQL, one with support for ClickHouse and another one without ClickHouse. The difference in size was very small, so at the end we decided that all the ProxySQL release now have ClickHouse enabled by default, and we dropped all the packages without ClickHouse support. In 2015, we introduced a new variable to better control transaction timeout. So previously we had a variable called MySQL max transaction time. This actually was incorrectly named because it was checking how much the transaction was idle. So now we renamed that variables in MySQL max transaction idle time, and now the variables with the same name previously, that was MySQL max transaction time, now it measures the world time of the transaction. Now, new features into one. This is the most interesting part. So we have enhanced the clustering solution. Now, all the cluster communication happen using SSL. That's by default, and it cannot be changed. So previously, communication with the backend was used to use SSL. Communication to proxy was using SSL, but between nodes was not using SSL. Now this is finally the case. Also, ProxySQL node will check their own version when connecting to other nodes, and if their version does not match, they won't be able to synchronize. So this is a fancy mechanism. So it is a protection to try to synchronize from a proxy that has a different version, so it might have different variables, so it won't be able to replicate. This is why they stop communication. Now, into one, with regard to cluster, we also are able to synchronize variables, so all the admin and the MySQL variables can be replicated, and we also synchronize the MySQL clusters tables, so the clustering solution, like MySQL AWS Aurora host group, and MySQL Galera host group, and MySQL group replication host group. We also perform some tuning of the parser, and now basically are able to replace decimal and scientific notion in numbers with just one single question mark instead of multiple ones. And we also remove unnecessary space around arithmetic operator. Also, with regard to MySQL Query Digest, we implemented new features that is able to group a long list of parameters in a shorter one. So it is very common to have queries in which that are mostly identical, but they differ by the number of parameters that are passed into an in clause. So what we do is that if the number of parameters goes beyond a certain threshold that is configurable, all the parameters beyond the threshold will be replaced with a series of dots. Also, we have implemented a replaceable SQLite plugin. So SQLite powers ProxySQL because it's the embedded database, and this is still the case in ProxySQL 2.1, but we are also able to replace it with a plugin that can have enhanced capability. Like, for example, the one we are going to plan is to have the ability of having encryption at rest. Here, quick overview. So basically, in ProxySQL 2.1, we add the slow shutdown. So this makes the ProxySQL shutdown command itself way faster. So this is very interesting for administrative purposes. Now, the most interesting part about 2.1 are the Prometheus exporter. Is Prometheus exporter and the enterprise web UI. So a quick overview. One of the issue we had that we solved into one is that we always introduce new metrics in ProxySQL, so we are able to export those metrics. If there is an exporter, a Prometheus exporter, this has to be an external services that has to connect to ProxySQL, execute some queries. ProxySQL has to parse those queries, understand what the exporter wants, generate the data, and pass them to the exporter. So this requires some processing. Then the exporter is able to send those data to the Prometheus server. Now, One of the challenges here was that, of course, it has some performance implication, but also every exporter needs to support multiple versions of ProxySQL because new variables can be added all the time. New metrics can be added all the time. So what we did instead was to embed the ProxySQL, embed the Prometheus exporter directly inside ProxySQL. So ProxySQL now is the Prometheus exporter itself. So this means that it's able to access the metrics internally to the proxy, and so this will have way higher performance. All you need to do is to configure the Prometheus server to connect to ProxySQL at regular interval to scrape those metrics. In interval will be 5 seconds or greater. So here is an example of how this looks like, the output provided by ProxySQL that Prometheus can digest. And of course, because those metrics come directly from ProxySQL, it is extremely fast. We are also developing some dashboards that we're making available. Those dashboards, of course, we try to put and display most of the useful information to understand how ProxySQL is behaving at a glance. So having just a quick look at this dashboard, you will be able to understand if the performance are correctly or if there is something that is misbehaving in ProxySQL. And you have multiple information like number of connection, the status of those connections, the status of the backend, the ratio between front-end connection and backend connection, and so on. Then you also have a lot of information related to the utilization of the connection pool, the amount of queries sent to every backend, the amount of traffic sent to every backend, and so on. Extremely useful information. And we're going to make those dashboards available, those Grafana dashboards available. Now, the enterprise UI. This is a very easy to use and powerful web UI. So ProxySQL is a service normally is configured only through terminals or through automation, but there is a barrier here, and we try to remove this barrier, making ProxySQL easier to use using a very powerful web UI. This web UI allows to have a quick overview on how ProxySQL is behaving, but also allow them a better management of ProxySQL and also make the configuration itself a lot easier. It is implemented as a plugin, and this plugin is available for enterprise subscribers. And so it has multiple pages. We have a dashboard. In this dashboard, we show very basic metrics about ProxySQL. The reason why we only have basic metrics is that we have the Prometheus exporter. So if you want way more complex, you can use way more complex dashboard. You can use the Prometheus exporter and the Grafana. And then here's where it comes the most interesting part. So from here, you are able to visualize all the MySQL users or the MySQL server, and basically here you can see all of them. And what you can do is you can delete them, you can edit them, and then you have the command drop-down menu in which you can execute basically log MySQL server to runtime, save MySQL server to disk, and so on. And you also can show data from the main, from runtime on disk. And of course, one interesting features here is that you can add new entries, of course. So you can add new users or new server. Here in this example, there is how it looks the page to add new users. You can basically configure this, adding username, password, maximum number of connection, the schema, the default schema, and so on. And another setting like if you want the user to use SSL or not. And similar things, you can have add new MySQL server. Again, in this page, what you will see is all the settings related to a new MySQL server. So the host name, the port, which host group ID it will belong to, the maximum latency, max connection, and so on. And of course, the same template applies to other tables, other configuration. Like for instance, you can add a new MySQL replication host group. And in this case, you will have the writer host group and the reader host group and the check type. But also you can have a MySQL Galera host group. So using this page, you are able to create a new host group. And same things apply for MySQL group replication host group and the Aurora host group. Of course, based on the clustering solution, you will have different type of information that you need to input. And this does not apply only for the MySQL server, but all the other tables. Like for instance, here you can see the query rules. You can edit them, but also you can create new query rules, very easy to use using this very simple page. If you are familiar with MySQL query rules, you know it has really a lot of columns. But here we only display the most relevant one, and you can specify if you want to add more, if you want to configure more columns. You just have to click on the one you want to configure and that are listed at the bottom of the page. Then another interesting feature is that you can configure admin variables and MySQL variables. Very simple, depending from the type of variables you can enable or disable, or if it is a variables that accept a string, you have a text box in which there you can write the setting you want to be applied. Then again, you have the command, so you can from the same page you can load them to runtime or save into disk or load from disk and so on. As I was saying, the admin variables and also the MySQL variables, absolutely the same thing. Also, you are able to configure the firewall. I'm not going to get into details, but basically the firewall feature is quite complex on its own. And you have this web UI that allows an easy configuration of the firewall whitelist, both for the users and for the rules. So it's extremely easy. You can do it from here. Also, for every tables in the stat schema, we are able to export metrics here. So you can have a search box, you can order them, so you can investigate the behavior of ProxySQL, absolutely everything from this web UI. Very, very easy to use. And that's it. Please remember that this features is available for enterprise subscribers, so the web UI won't be publicly available. Thanks, everybody.